Hey guys, so this video is the part 2 about our project of using AI to predict the next Formula 1 USA Grand Prix winner. So yeah, those last days I have been working super hard to try to finish this project so that we can get predictions on time to see actually whether the AI will be right or not. By the end of this video, I will tell you what did my AI predict as the next winner of the Formula 1 USA Grand Prix. So yeah, let's get right into it. First guys, I wanted to talk about some challenges that I have been through for this project. First, it was a bit hard, to get used to this library, this fast F1, because there are so many things, that you need to take into account, like the format of the data and the different functions and, the documentation of this library is quite complicated. Thankfully, I used ChatGPT. It was quite helpful, but less helpful sometimes, because even though it was able to provide me with some boilerplate code, it was still hallucinating sometimes, so I still have to know how to code, obviously, to debug when there are some weird errors, and you always don't know how to fix them, basically, and you need to look at the code manually and to see if it makes sense or not. And also I had to double check the suggested code, because sometimes, even though the code was running, there were still some bugs. For example, one simple thing, is about retrieving the number of races every single year. So, for example, we can see that in 2024, via the official Formula 1 website, we can see that in this year, there were 24 races, right? But sometimes if I used only what ChatGPT provided me, sometimes it will find only 18 races and sometimes 20, So I had to double check manually to see if it makes sense. And then if there were some errors, I had to basically double check and debug on my own. Also, there were some issues related to the API rate limiting, because basically this library allows you to get data, and it will make some HTTP requests, basically, but you can't always rely on that, because behind the scenes sometimes it will make a lot of requests and you can be throttled basically by the servers, and those servers will tell you, hey, you made too many requests, you should pause, and come back later, basically. Another useful alternative that I found is to download all the data from 2018 up to 2025, so that I don't have to basically fetch anything else from the internet. So yeah. Now, moving to the interesting part about the feature engineering. So remember, I told you that feature engineering is about selecting the inputs that will most likely affect positively the accuracy of your AI model. Basically, what is the information that your AI will use that will make it super accurate. So yeah, at first I wanted to use 22 features that I thought would be useful, but then reality hit. I had to move fast, and let me show you here. For this USA Grand Prix race, there are only 11 hours and 48 minutes left, for the race to start. So basically I had to go super fast, and whenever there were some features that were either hard to find, or I realized that the code to build them was too complicated, I just gave up on them, basically. So yeah, basically there were 9 features that I didn't use at the end of the day, because either the data seems too noisy, for example, everything related to the tire strategy per driver and per race. Whenever I started, getting this data, it felt weird, and I didn't want to dive into too much technicalities related to this specific feature. Other than that, there are some features that are simply hard to get, because let's say I wanted to use like the air temperature forecast, the humidity forecast, but for those specific features, well, first of all, this library doesn't provide them. So we need to rely on like an external API and website. But I didn't find any website that provides like an archive of the forecasts, basically. So since I realized that it would be hard, I just said, okay, let's forget about it. And there are some other features that I found redundant, and I will tell you more about that later on. So this is the list of features that I finally used. So the first one is the average lap time the last year for the same circuit. So let's say in one data sample, so as a quick reminder, one data sample in AI training is about the mapping of one input, or like a list of inputs to an output. And for this particular problem, the list of inputs is the one that I will show you, and the output is like the finishing position in a race. So either first, second, third, and so on. Here, for example, let's say that the target output is the Singapore race for Hamilton, and let's say, I don't know, he was placed second in the year of 2024, for example. Here, the average lap time of last year and same circuit will do exactly that. It will just, basically fetch all the lap time, all the times, for all the laps for Singapore in 2023, and basically average out all those lap times, basically. Then I did the same for the second feature, but here it is about the fastest lap time, basically. Then I also computed the number of overtakes during the last 3 races, and this will actually put an emphasis on the momentum, on the current momentum of this driver. And also similarly, the average points during the last 3 races for a driver, to also put highlight on the dominance of a driver, basically. And then I also chose the driver average finish on a particular circuit, and then a driver best finish on that circuit, and then the driver experience level. So how many years does this driver has been on the Formula 1, and then for one circuit the number of laps, because maybe some drivers are better when there are more laps, and some other drivers are less comfortable when there are fewer laps. The number of corners, the month number, because the month directly implies the seasonality, whether it is raining, whether it is dry or hot, and so on. And then I also encoded the driver ID and the team ID. By team ID I mean McLaren, Ferrari, and so on. Then this is the list of features that I had to ditch. The first one is about the tire strategy the last year in the same circuit, the driver rain performance, which means like the average finish when there was rain, in a race, and on the contrary, on the opposite, the driver hot temperature performance, like the average finish when the air temperature is greater than 30 degrees Celsius. And I thought that this feature would be useful for races like the Bahrain, Saudi Arabia, and so on, basically in races where it's super hot. And then I also had to ditch rookie flag, basically whether it is the first year of experience of a particular driver or not. And this one is pretty redundant with this one, because it's more or less the same thing, right? Other than that, I also had to ditch the circuit length in terms of kilometers, because I thought this would be like super easy to get from the library, but believe it or not, it was impossible to get. And if you're a viewer and you know how to fetch it, please let me know, because I couldn't. Other than that, I also had to give up the surface type, basically whether it is asphalt or like city and so on. And then, as I told you already, I also had to give up all those weather-related features. And the model that I used is called XGBoost. It is a model that is widely used in machine learning to do many types of predictions. So I just decided to use something that is very often used in machine learning, basically. Then the next thing that I wanted to talk about for this project is the approach that you take, to tackle this type of projects, because basically there are two types of approaches that you could use. If we use a regression approach, we will basically try to predict the performance at the level of a driver, and the risk of using this approach is that we would end up, the model would end up predicting multiple drivers with the same position. For example, Verstappen with Hamilton, both on first place. And it doesn't make sense, right? But actually what you need to do for this project, basically the AI needs to learn to rank drivers, given multiple races. So that's what I used as an approach, basically a ranking approach. Concerning the data set that I built, I will show you guys the code snippet, but it is very long. So this is the file, that I used and that I wrote, basically me and ChatGPT as a copilot. And as you can see here, it is still downloading and preparing the dataset. So I couldn't use basically all the datasets from 2018 up to 2025 to basically train the AI. What I did to actually have enough data to train the model without waiting, for all the dataset to be ready, I just used a subset basically of all the data. Basically, I used races spanning from 2023 up to 2025. Now guys, the exciting moment that I have been waiting for after training the AI, what is the prediction, the final prediction of my AI? So let's see it. Basically, my AI predicted that in the first place there will be Verstappen from the Red Bull Racing team, and then on the second place there will be Russell from the Mercedes team, and then on the third place there will be Norris from the McLaren team. So yeah, I'm super excited to see what will end up happening. And yeah, as I've wrote here, I actually have like a full ranking prediction, and basically I will be comparing once the race will be over. So as you can see, this is the full ranking and I will be comparing, so as you can see, on the first place Verstappen, second place Russell, and so on and so forth. So yeah, super exciting. So now guys, let's place some virtual bets to have some fun. Now if we go to Polymarket, we can see that, yeah, definitely Verstappen is the clear favorite, and I already placed an amount of $1,000 to see what will be the reward, and you can see that we have a 1.578 odd, so yeah, this is the expected payout if I bet right now. So let's just say, okay, I just place a bet, and then let's check bets 365, and we can see that here for the USA Grand Prix, for the winner it will be if it's Max Verstappen, it's 1.53, which is a bit less than Polymarket, because here it's 1.57. But yeah, let's say that I placed $1,000 for each of those platforms, and let's see what will happen after the race. Okay, so now I have done the biggest part, which is getting our first prediction and getting the dataset ready, even if it is not 100% ready for now, but it is still being prepared at the moment. There are still many ways to improve the results. The first one would be obviously to use more data samples. So as a quick reminder, I used only from 2023 up to 2025. What I can do is just to wait for all the data to be ready and then use all the data available from 2018 basically. I can also play on the model parameters. So what I mean by that is that this is the AI model that was used to be trained to learn to make accurate predictions basically. So all those parameters that you can see here, the learning rates, the number of estimators, the max depth, and so on, I could play on them to either increase them, decrease them, and so on, and see how this would affect this number that you can see here. So this mean NDCJ, it's basically a metric that is used to determine the accuracy of our model. And the more it is close to 1, the better, basically. So as you can see, for now, it is 0.7754. And let's say I will just, here, this learning rate, instead of 0.09, I will just set it to 0.08. Let's run it again and see how it will affect this score here. So let me run it. So as you can see, it is a bit worse. It's 0.75 now. So let me just put it back to 0.09. But as you can see, there are so many ways. I mean, for this model, we can, try many parameters and basically just search and then run it every single time to see whether we can increase this metric or not. Other than that, we can obviously use more features, like I could dedicate more time to try to find, those archives of forecasts, or try to see whether I can add the tire strategy and so on and so forth. And obviously we can use other models. So this XGB ranker, it is one among many models. I could use something else called light GBM, which is also used for ranking. I could use neural networks. I could use, many other things. I could even use like multiple models, and then the final prediction could be like an average of those models, So yeah, there are so many things that could be done to improve these results, but I think it's already quite encouraging. And yeah, as you've seen, we have been through like some explanation of the project. Why did I choose this approach? The features that I used, the model that I used, and yeah, basically you will have this code available on Discord. If you join the Discord, you will be able to download it. So yeah, guys, thank you so much, and see you next time. Cheers.